The SF26 was flat through turn 12 in Bahrain, throttle pinned, rear stable, the car barely moving under the driver. On timing screens, the Delta glowed purple. Engineers along the pit wall didn't react. They didn't need to. They already knew what that lap meant, because the version circulating through the desert heat wasn't the real car. The side pods were too big, the cooling too generous, the bodywork too cautious, and yet the lap time was a 1 minute 31.992, the fastest of the entire 2026 preseason by 8/10. So why would Ferrari hide performance behind bulk? Because what mattered wasn't Bahrain, it was Melbourne. And the most important innovation on this car isn't visible from the outside. When Ferrari rolled out in Barcelona in late January, the reaction across the paddock was uniform. Oversized side pods, bulging radiator packaging, conservative cooling architecture. The airbox told the real story. It was the smallest on the 2026 grid, a narrow triangular opening that signaled something radical. Zero centerline cooling, every radiator packed into the side pods, nothing running down the spine. That choice dictates everything. Barcelona wasn't about performance, it was about reliability baselines. Ferrari debuted a brand new 067/6 power unit with new internal materials. You do not immediately shrink cooling margins when combustion pressures are reaching levels by their own admission never previously achieved. Then Bahrain arrived. 2 weeks of desert heat, a second side pod specification, wider entry section, still not the race configuration. Engineers weren't chasing lap time, they were building thermal maps. The key question wasn't how fast the car was, it was how small they could make it. And the answer, according to Italian reports, is dramatically smaller for Melbourne. But that wasn't the real story. Let's talk about numbers. 131.992, 8/10 clear of Mercedes, nearly 9/10 over McLaren. Headline testing times are unreliable. Fuel loads, engine modes, tire compounds distort everything, but consistency matters. Ferrari's race simulations were among the strongest across both test weeks. They completed the equivalent of 14 full Grand Prix distances without major failure. 14, under desert heat, under new combustion architecture. The only scare, Hamilton's engine shutdown, was later confirmed as a deliberate fuel pickup test. And the regulation shift matters here. Power unit minimum weight rose from 120 kilograms to 150 kilograms in 2026. 30 extra kilograms of headroom. That absorbs a material penalty most teams would fear. Steel instead of aluminum no longer represents a catastrophic compromise. Numbers alone don't win championships, but they reveal confidence, and Ferrari's numbers suggest something structurally different is happening beneath the surface. Every other manufacturer, Mercedes, Red Bull, Ford, Renault, Honda, uses aluminum cylinder heads. Ferrari chose steel. That decision sits inside the combustion chamber, invisible to cameras. But it reshapes the car. Steel withstands higher combustion pressures and temperatures. More importantly, it insulates more effectively. Heat remains in the chamber instead of bleeding outward. Less escaping heat means reduced cooling demand. Reduced cooling demand means smaller radiators. Smaller radiators mean tighter side pods. Tighter side pods mean reduced frontal area, cleaner airflow to the floor, improved rear downforce generation. This is engineering integration at its highest level. Engine dictates cooling. Cooling dictates bodywork. Bodywork dictates aerodynamic efficiency. Most teams optimize these domains separately. Ferrari aligned them. And once that alignment works, rivals cannot simply replicate it. Switching cylinder head materials mid-season is impossible. This is foundational architecture. It requires new manufacturing processes, new durability validation, months of dyno testing. Ferrari nearly abandoned steel in October 2025 due to durability failures. Early heads could not survive thermal cycling over race distance. Guido Deppa returned to the drawing board, partnered with AVL, solved the issue. Engine director Enrico Gualtieri signed off, and Ferrari scrapped the aluminum backup. Steel or nothing. Mercedes' philosophy remains aluminum with more centerline cooling bulk. Red Bull Ford's power unit focuses on energy deployment. Neither can pivot before 2027 at the earliest. Audi might, because they hired Wolf Zimmermann and Lars Schmidt, the original developers, but not for Melbourne. This is a 2026 only window of exclusivity, and Ferrari understands exactly how rare that is. While attention drifted towards sidepod volume, Ferrari deployed two headline-grabbing innovations. First, the exhaust wing, internally called FTM, a small element behind the exhaust pipe redirecting gases toward the underside of the rear wing while acting as a gurney for diffuser extended bodywork. Enabled by moving the differential rearward within regulation limits and exploiting a 60mm aerodynamic device allowance. FIA review lasted weeks. It was approved. Uncopyable without gearbox redesign. Then came the rotating rear wing. Approximately 225 degrees of rotation. Active aero transitions must complete within 400 milliseconds, but no maximum angle is specified. Ferrari exploited the gap. Hamilton gained roughly 10 kilometers per hour on Bahrain straights. Every headline focused on that, nobody focused on shrinking side pods, and that may have been intentional. Frederic Vasseur's phrasing was controlled. Yes, but no more and no less than McLaren, Red Bull, Mercedes. Competitive parity disguised as humility, but he emphasized something more revealing: development capacity. He stated what matters most is the ability to bring parts quickly, not performance at race 1. Ferrari already deployed 3 sidepod specifications before lights out. That signals infrastructure readiness. Technical director Loic Serra described strengths at the rear of the car and in the floor area. Under ground effect regulations, that is decisive. Rear stability equals consistent aero platform. Consistent aero platform equals tire management. And tire management defines race pace. The language was collaborative. Systems focused. This is no longer isolated brilliance. It is organizational cohesion. Charles Leclerc's 1:31.992 was headline material. But race simulations were more revealing. Full distance run at the hottest point of the final Bahrain day. Practice starts dominant. The smaller turbo configuration delivered faster spool up, launch advantage into Albert Park's long run to turn 1. Paddock consensus still places Mercedes as slight favorites. Ferrari and McLaren close. Red Bull 4th, but integration is Ferrari's differentiator. Mercedes may have peak power. Red Bull may deploy energy most efficiently. McLaren may develop fastest. Ferrari integrates engine, cooling, aero, and mechanical platform into one philosophy. That cohesion is difficult to outdevelop. In 2024, Ferrari finished 14 points behind McLaren. 5 race victories, 22 podiums. Momentum existed. Then 2025 collapsed. The SF25, the 99% new, suffered ride height sensitivity due to a shortened gearbox casing. Floor had to be raised in Melbourne 2025 to avoid plank wear. Downforce disappeared. 8th and 10th, no wins all season. Development halted by April. 8 months redirected to SF26. 8 uninterrupted months. Vasseur admitted the psychological toll of knowing 20 races remained with no upgrades coming. That pain purchased development time. The 2026 car was built in calm, not crisis, and that changes everything. Albert Park runs 72% full throttle, 3rd highest power demand on the calendar. 4 DRS zones reward low drag efficiency. Steel-enabled tighter side pods reduce frontal area across each straight. Turn 11 and 12, taken at approximately 225 km per hour, demand rear stability. Serra highlighted rear and floor strength. Heavy braking into turn 1 at over 300 km per hour rewards launch performance. Ferrari dominated practice starts. Smooth resurfaced tarmac allows aggressive ride heights. Maximizing ground effect. Ferrari has 11 victories at Albert Park. Tied with McLaren. History aligns. Architecture aligns. Track characteristics align. Now the only remaining question is execution. Ferrari's advantage is not a single device. It is not the exhaust wing. It is not the rotating rear wing. It is not even the 10 km per hour gain in active aero mode. The true advantage sits inside the combustion chamber. Steel cylinder heads reduce thermal bleed. Reduced thermal bleed reduces cooling demand. Reduced cooling demand shrinks bodywork. Shrunk bodywork enhances floor performance. Enhanced floor performance stabilizes the rear, that is systemic design. And systemic design compounds. The risks are real. Mercedes may have hidden pace. Hamilton's reduced running raises minor uncertainty. Testing illusions have misled Ferrari before. 2025 proved that brutally. But structural integration is harder to fake than lap time. 8 months of focused development are already baked into the chassis in Melbourne. The side pods we saw were not caution, they were calibration. And if the third specification delivers the aerodynamic step internal data suggests, then Melbourne will not be a surprise, it will be confirmation. If Ferrari's steel architecture creates a cooling and packaging advantage that rivals cannot replicate before 2027, and if that advantage compounds through development rate, are we about to witness the first season in the ground effect era where Ferrari dictates the aerodynamic conversation instead of reacting to it? Because if Melbourne confirms what Bahrain only hinted at, this will not be a one-race statement. It will be a structural shift.